Welcome to the next video on compiler design. In this video, we are going to talk about operator precedence grammar. So let us start. A grammar has to satisfy the following condition for it to be passed by an operator precedence parser. That is, no epsilon productions are permitted, thus ensuring that the RHS of all productions should be a combination of terminals and non-terminals. The RHS of all productions should be in such a way that two non-terminals are not going to be adjacent in any of the production rules. Okay, and for any pair of terminals A and B, never more than one of the precedence relation, that is A lesser than B or A is equal to, us A is having same precedence as B and A is greater than B is true. Okay, so an epsilon free operator grammar satisfying these conditions are going to be called as operator precedence grammar. Suppose we have to find out whether the given grammar is operator precedence grammar or not. Having this production, E is rewritten as E plus E, E multiplied by E, in parenthesis E and ID. So we will see that this grammar is not an operator precedence grammar because two precedence relations hold between certain pair of terminals. We are going to prove it, but for that we should have the knowledge of these rules. So let G be an epsilon free operator grammar, that is no epsilon production. For each terminal symbols A and B, the following condition need to be satisfied. What? We define three symbols to define the precedence relation between two terminals A and B, namely the same, lesser and greater precedence respectively. Okay, so how these rules are or how these relations are calculated? So the first rule talks about same precedence relation. We say A is having same precedence level if there exists a production in RHS of the form alpha A beta B gamma, where beta is either epsilon or a single non-terminal. For example, consider the grammar with a production S is rewritten as ICTSES. Now comparing this with this production form, we can have same precedence level for I and T and then T and E. How? Just consider ICTSES. If we compare A, beta, B and this whole portion as gamma. So this here relation holds. I is equal to T. Again, in the same case, ICTSES, this portion becomes alpha A beta B gamma. So again, T has same precedence level as E. So you can see beta can be epsilon or single non-terminal. Here beta is C single non-terminal and here beta is S single non-terminal. In this way, same precedence level is defined. Next, lesser relation. Two terminals are there, A and B. A has lesser precedence B if some terminal A is existing. For that terminal, non-terminal, a production in RHS of the form A is rewritten as alpha A A beta and A derives in one or more step gamma B delta, where gamma is either epsilon or a single non-terminal. Just consider the example. Suppose S is rewritten as ICTS and C is deriving in one or more step B. Fine. So just compare it with this form. Here A is what? I, and then C is producing B. So I yields precedence to B, or I has lesser precedence than B because C derives B. Fine. So in this way lesser relation are determined. Next, greater than relation. Again, two terminal symbols are there. A has greater precedence than B if for some non-terminal A there exists a production in the RHS of the form alpha A B beta, and A is deriving in one or more step gamma A delta. In this case, just see the last part, that is delta, is either epsilon or a single non-terminal. In lesser than relation, this gamma is either epsilon or single non-terminal. In greater than relation, delta is either a epsilon or a single non-terminal. Again, in the same relation, just see S is rewritten as ICTS and C is deriving B. So here this portion A is C and C is deriving B. So ultimately we are getting that B is having greater precedence than T. Okay. So in this way, same precedence level, lesser than and greater than relation is being determined. Now consider this relation for the given grammar. Just consider this production. E is rewritten as E plus E. Okay. Let this right side be alpha A B beta, where alpha is epsilon, A is E, B is having this symbol plus, and beta is E. Okay, so we can see A deriving in one or more step gamma A delta, that is in this case E will be deriving E plus E in one or more step. Fine. Where gamma is this symbol, non-terminal E, A is again this plus, and delta is what? This E. Okay. So just go to previous slide. We are having delta as either epsilon or a single non-terminal. Fine. So in this case, what happens? A is having greater precedence than B. So what happened here? Plus is having greater precedence than B. Again, for the same production, just compare like this. E is rewritten as E plus E, E alpha A A beta. For lesser relation, alpha becomes E, A, and this E becomes A, beta is epsilon, and as we know, A is deriving in one or more step gamma B delta. So here E is deriving in one or more step E plus E, where gamma is what? E, B is plus, and then delta is E. So, if you remember, just see lesser relation. A is deriving alpha A beta, and A is deriving in one or more step gamma B delta. So ultimately A will yield precedence to B. So in the same way, here plus will yield precedence to B, or plus has lesser precedence than plus. So ultimately what happens for this terminal, plus we are having greater than and less than precedence level. So in this way, this grammar is not an operator precedence grammar. Okay, these are the references. Thank you for watching.